Yeah, I'm Peter Ullrich from Germany, and today I would like to talk about event sourcing, what it is, what you can use it for, and how to get started with it using Elixir. But let me first explain to you why you would use event sourcing and what you can do with it. I just picked 6 different things you can do with it, but if you have your own use case that you might apply it to, go ahead. And I hope that you can get started after this talk with it. So the first thing that you can do with event sourcing, which is hard to do with other technologies or other techniques, is auditing. So if you work in an industry that is regulated and where you have to comply with certain laws, you have to prove every now and then that your software, your system, is working according to certain rules and regulations. If you use event sourcing and you store the events that you produce along the way, you can prove that to the regulators, and your compliance work will become much easier and much more cost effective. You can also use event sourcing to audit your own system yourself. It's not only for third parties, it can also be very handy for yourself. So if you have larger systems with larger distributed systems particularly, you can nicely look at your business processes that you model in your software. And then you can see how these business processes work, how fast they are. Maybe there's some bottlenecks in there. So you can nicely analyze your system based on the business need, the business value you need to provide. So auditing it's a big point of event sourcing. And once you have it enabled, event sourcing, or implemented, you can also nicely use it for debugging purposes. So if you, again, have a distributed system with many services, it will become hard to see what is going on where and when and so on. Like, it's hard to stay on top and keep the overview of everything. And event sourcing is helping you with that. So if you have multiple services and they all create events, you can later on see which events happened in which order and when, and so on. So debugging is it's a very big topic as well. Once you have event sourcing, you can also create historic state. It's also called as time travel. So let's say you have a trading platform and you want to go back to a certain point in time and recreate that state. You can do that with event sourcing. You couldn't do that if you don't keep track of the history of your application, which you do with event sourcing. And once you reach a historic state, you can also create alternative state. So you can say, in the trading system again, let's say, okay, what would have happened if I hadn't had gotten that particular pricing? If I hadn't made that trade, like would I be now better off or worse off, and so on? So you can do some simulations with your application. You can also recover lost state. Nowadays, obviously, it's very easy to create backups and rolling backups and whatnot. But you can also look at event sourcing as another technique to recover state once you lose it. If you use event sourcing for recovering lost state, you can also employ a technology called memory image, which lets you get rid of the database you have and keep everything in memory in processes, which will speed up your system tremendously because you don't have I/O inputs and any latency between your service and the database anymore. So it will speed up your system tremendously. But the problem with keeping everything in memory is, of course, if your process dies, if your server goes down, whatever, you lose all that state from the RAM, basically, from the memory. So then you can use event sourcing to recreate that state quickly. So there are a couple of things. I hope you found a use case that you are interested in. So because now I would like to talk about what is event sourcing actually. And it's a technique you can use like any other if you use it, if you want to use it. And it has 2 very basic steps. The first step is you document every application state change with an event. So whenever you create or update or delete something in your system, you create an event that has as a payload whatever you have created or deleted or updated. And then you store that event in a separate storage system. Doesn't need to be separate though. Depends on whether you care about the recoverability feature that I explained earlier. But you can also keep it in the same database as your application. But in this case, if your application database goes lost, the events might also be lost. And these are all the 2 steps you really need to do. It sounds simple. There's more to it, of course. But particularly the first step, just document every state change. That's basically what you need to do. But this is a little bit abstract, so let me tell you about an example so that you understand much better how you can use it in your own software. Let's say we have a model, a database model, a schema, and it has 4 fields like an ID, a destination, a delivery date, and a very naive way of keeping track whether the shipment was delivered or not. And now let's look at the life cycle of an entity, or like an object of a shipment. And the life cycle of an entity mostly starts with a creation. Actually, it always starts with a creation. And then, for example, in this case, you create a new shipment. Some customer told you to ship something from A to B, and you just register it in your database. Now, as I said, every state change needs to be documented. Creation is also a state change, so you also create an event while you create the shipment in the database. And that event can be called shipment registered, and it has a payload of with ID 123. So if you're a little bit into domain-driven design, you will see this is nice language that is like the talks that explains itself. So this event would be called shipment registered with ID 123. It's like a sentence. And then whenever you update that shipment entity, that object, you would, like for example here, you set the destination where you want the shipment to go to. You again create an event that has as a payload everything you need to recreate that state. So you say a destination was specified for the shipment 123 with an address memory lane 1, for example. And again, also when you schedule the shipment, you update in database and you also create an event. And when the shipment is eventually delivered, hopefully successfully, you update the model again and you create an event. That's basically it. This is event sourcing. And now let's talk about how you can use these events for example, for recovering lost state. Let's say that you delete the entire production database and everything is lost except for your events. We would then take the events, order them, sort them chronically, and then we take one event after each other. So we say, first we take the shipment registered event, and we call the same function again as earlier. We create a shipment. We get to that same state as before. Then we do the same for the destination specified, and we also create that shipment again. You see, this is also how you would create historic state. So at this point, I could stop. I can say, okay, this timestamp, what is my current state? And now I see what it is. And now I could create alternative state by not, for example, using this event, by skipping it, and then see how the system would behave differently. So that's basically how we do it. Then you consume the other events, and eventually you arrive back at the application state that you had previously. So that's how you recover the state. And what I explained to you now in like 3 minutes is basically everything you need to know about event sourcing. That's how it works. It's not that much to it. Then there's one more thing, though, that you should know about, that you should have heard about to understand also the library, the EventStore library I will present later, and that's the streams. So a stream is a sequence of events that are related to one particular topic. So typically you create one stream per entity. So if we have a shipment with the ID 123, you would create a stream, for example, shipment 123. And then any event that occurs for that entity, for that shipment, you link to that particular stream. Because eventually I can just look at this stream and I see the entire history of this particular entity. That's a stream. So now there are 2 more smaller things that you should have heard about at least. I always mix them up, so don't feel bad if you do the same. And they are called causation and correlation ID. The causation, so every event has these causation and correlation IDs, and you should set them in order to get the full features from event sourcing, the full functionality. And the first thing is the causation ID. The causation ID of an event is the ID of the event or the command that caused this event to happen. So for example, we received a shipment, and we created the shipment received event. And because we received the shipment received event, we then kicked off our scheduling algorithm and eventually got a response back. And with that response, like the delivery date, we created another event, which is called shipment scheduled, for example. So this event, shipment scheduled, was created because of the shipment received event. So that's why the causation ID of this event is the ID of the shipment received event. That's a causation ID. And then also, like, because we scheduled the shipment, we also have to designate a vehicle for the delivery. And again, we did that only because the shipment schedule event occurred. So that's the causation ID. And the second thing you need to know is a correlation ID. And that is an ID that goes all the way back from any event in the chain of events, goes all the way back to the original first event or command that occurred. So in this case, we have a vehicle designated for delivery event, and the correlation ID is the initial, the ID of the initial event. So this way, if I only look at this event, I know, all right, this event only occurred because way back in the beginning, this event occurred, and then I can connect, these two events. So that's quite technical. One more thing, though, you can also create streams for whatever topic you like. For example, you can create streams that, in this case, keep track of every registration we make in the system. And then if a shipment registered event occurs, you link that event to this stream. That's a technical term. You link it to the other stream, and you can collect all these events on a separate stream as well. This is really good for analyzing your event store and just keeping an oversight of what's happening. So I could look at the shipment registration stream, and I know how many shipments were registered, how often, and whatnot. So that's another technique you can use with the event store library. All right, this has been all the conceptual part that I wanted to talk about. And now I will go over to the part where I actually show you some code and where I tell you how you can get started using Elixir. Okay, so this is an example project that I also put on GitHub. The link to the GitHub repository is in the back of the slides. Otherwise, you can look at my GitHub. It's PJ Ullrich, Ullrich with 2 L. And this GitHub repository has 2 folders. One of them is an extended example that I created, but now I didn't have the time to present, unfortunately. And it shows you how you can create 5 different services that model a logistics system, then communicate using the event store library with each other. Yeah, so you can just run this, go to localhost 4000, look at the UI, and yeah, maybe it helps you further with getting started. But today, for this talk, I will only focus on the demo folder here, the demo project, which just is a very tiny project to show you how to get started. And the first thing you need to do to get started is import the event store library. This is the commanded event store library, which is used quite a lot and also in production already. And as a second dependency, I would recommend that you import the JSON library, because later on you can store your event data as JSON in your database. Once you have done that, you need to configure your event store. So in your config, EXS or wherever, you tell your application that you have an event store, and the event store, you tell that it should connect to this database, to this Postgres database. This can also be a URL. It's not too different from the normal repo configuration you do. But the important part here is this. So there are 2 different ways of storing event data, the payload of an event in the database. One of them is to use the Erlang binary. It's its own format by Erlang, which I think keeps the storage costs low. Like it has a smaller footprint in terms of storage. But the problem with just storing your event data as binary is that you cannot search through it. that you cannot look at your database and just look at the rows in your database and see what the data of an event is. So that's why I recommend you, if you use this, to set the column data type, so the type of the column data, to JSONB. And this way you will store the event data as JSON, and you can just look and enter it in and analyze it and query against it even in the database. So just as an example, I will show you the example database I have here. So you can see that there is like the data column type of these events, and they are stored as JSON. So I can see here now what the payload was and what the metadata was. And this is handy if you want to query directly here. It's much better, I must say, for debugging purposes. Okay. Whoops, let me just move this back. Okay, moving on. Now you configured your event store. There are two functions you have to call, two tasks. One of them is event store create to create the database of the event store, and event store init to initialize the tables and basically the tables, the migrations, to run the migrations if you want to. And after that, you're set. You have a database where you can store the events, and you can get started by publishing some events. Now, with the event store library, the event store library is quite minimalistic, or like low level, so to say. And I think it's a design choice by the creators, because this way you can customize it any way you want, which is good. But it means that if you want to get started, you have to create your own abstractions, which I recommend you to do. So if you want to publish any event, you could immediately call the event store append to stream function. So this appending to stream is creating an event, publishing an event basically. But you see that there's some things like that you don't want to copy paste to every part where you actually use the event store library. So that's why I recommend you to write two adapters for the event store library. And one of them is the event publisher. As you can see already, it has a simple publish function that is given a stream UUID. It doesn't need to be a UUID. It can be any string that you want. Like it could be a hashtag shipment123 if I wanted to. You give it the event that you want to publish, some metadata, which I will talk about later, and a version. And the versioning here is interesting if you care about concurrency and particularly race conditions. So if you have two processes or two services, whatever, writing to the event store simultaneously, you might add one event before the other event, but you might not want to do that. So in that case, you can now then here give like an integer as a version. So you say, I have my event 0, and then I have an event 1 and event 2. And event 2 cannot be inserted into the database before event 1. And this is what you would do with the versioning here. But if you don't care about concurrency, you can just use any version, and the event store will just write it to the database, not necessarily in the right sequence, in the sequence that the events occurred. Okay. So this is everything I have to say about the event publisher. This is like also a small, how you say, it's a small example. Like there's a more extended example in the extended example folder. So let me now tell you how to recreate the how to recreate the functionality that I presented to you earlier. So earlier I told you about the lifecycle of like, and now this here would, for example, be the first step of that lifecycle. So I have my service, whatever, and I have the function called create shipment with a certain ID. And so this just kicks off the lifecycle. I would persist that new shipment into the database normally, do a repo insert with a new struct if I wanted to. Actually, this should be a change set, but you get the point. Then I would, and now I said, I made a state change to the application. Like I created something, and because of that, I need to also document that change with an event. So I defined this shipment registered event, and I created with a payload with ID. So it also says shipment registered with ID, and I published that one. This like which stream ID you would give for a shipment. So ideally not in here, but somewhere else. But yeah, with this, I just specify the event should be added to a shipment 1, 2, 3, for example, stream, and the event, and some metadata. The metadata of an event can be quite useful. Like it has all the data that you might need to debug anything in your system. It usually has some timestamps of the event, which are also interesting. And what we usually do is we add an acted by field. This acted by field lets you identify who caused a certain event. So when a customer is creating a shipment, then you can say here, all right, this customer with that ID created a shipment at this point in time. You can also use that for logging purposes. Like if one of your employees wants to access some data that might be confidential, you can also, when the data is accessed, you can create an event for that and say the data was accessed by this person at that point in time. This is what you use the metadata for. A quick thing about defining your events. So I had this shipment registered event. It's very small. It's just a module with a struct in it, with a definition of a struct. One recommendation, if you have multiple teams or multiple services, you might want to put these definitions into its own GitHub repository, or repository in general. And it helps if you change anything in these events. It helps to track that change and also update the versions of the events you have in your services. And also, if you have multiple teams, it just helps a lot with communication between the teams, because then you don't need to ask, like, did this event have that payload or something else? You just put it into one repository, you put it into your project, and then everybody has the same definition of the events. That's also interesting. Okay, so now that we published some events, we also might need to consume them. So you can use events also for communication, not only for analyzing stuff. And if you want to react on any event, you need to write an event consumer. I'm just going to show you this one. So the event consumer just handles any event that it cares about. In this case, I match only against the shipment registered event, and I handle it somehow. And all the other events that come to this event consumer, I just ignore. And again, I told you, you should maybe write 2 adapters or 2 abstractions on top of the event store. And the second one is the event consumer abstraction. And what it does is it creates a new gen server process, or like a gen server in general, for every consumer that you want to create. So that if the consumer fails, crashes, whatever, you can just restart it, and not your entire system goes down when you cannot handle one event. You just start the event consumer, like usually, and then once it's started, you subscribe to either all the streams. So in this case, I would get all the events that happen in the event store, which might not be that performant if you care about if performance is really critical to you. This might not be the most performant way. So if you don't want to do this, you can also subscribe to single streams. And then you can use like topic streams, for example, shipment registered stream. And as a consumer, you would only subscribe to that topic stream, and you don't get all the events in the entire events. Subscribe to all the streams there are, so I get all the events. And that's it. So you just have to subscribe here. And once you subscribe successfully, you get this callback. And if any event happens, if any event is published, you get this handle info callback with events. It can be a list of events. It isn't a single event every time. So I just, in this case, just iterate over them, give them to my handle event function, which also just extracts the data that I actually care about. And it hands over that data together with the entire event, which also includes the metadata. and it gives over that event data to the event consumer module that I specified. And I expect that event consumer to acknowledge or to just say, all right, I processed that particular event. And if that happens, I acknowledge that I received that event, so that the event store doesn't try to send the same event to me again. Okay, this is a bit of macro magic that I stole from my colleagues, the awesome Andreas and magnificent Ede. So this is just, you define a default handle function, which you can also override by any implementing module. Like in the case of the event consumer, I used this abstraction and then overrode the handle function with arity2, and I only match against the shipment registered event. So any other events I will just acknowledge, but basically I will ignore these other events because I don't care about them. Okay, so I got only a couple of minutes left, so let me go to back to the presentation, because they are like, now you know a bit about how to get started with the event store. I'm sorry if this is really rushed, but again, I have an extended example on GitHub. You can look through it. The demo folder is also going to be there, so you can, in your own time, go through it and see how it works. But one thing you need to know if you want to use the event store is what kind of architecture you want to build upon it, or in which architecture you want to integrate the event store. And if you look at the extended example or folder that I have on GitHub, you will see, oh, sorry, wait. You will see an architecture like this. In the extended example, I have 5 services that all communicate through one event store database. And this works, so you have some communication between them. But the big problem here is that you have a very heavy buy-in onto the event store library, and particularly its Postgres schema. Because the event store has its own schema as it does, but the problem here is if you want to add any other service that does not use the event store library, then you will have a problem. Because let's say you want to add a Ruby service to this, like a legacy Ruby service or a Java service or whatever. These services also need to use the same schema and need to update the events and insert the, not update, but insert the events the same way. And this is almost not possible. So if you use the event store like this, like a spider in the web, basically, then you're not flexible with adding any other technologies. So what you rather want to do, I recommend you to do, is to use something that is technology agnostic in the middle. So in my company, we use RabbitMQ to communicate between all the different services we have. And those are Ruby services and Elixir services. And both of these languages have really well written and tested libraries that connect to RabbitMQ for us. So we can just connect the services through RabbitMQ and connect basically any language we want to. If you want to do Java in one point in time, we can add it to it. So like rather use something agnostic in the middle than the event store library. What you can do, however, is inside your Elixir services, if you wanted to, have one shared event store instance, but rather stick to the thing in the middle, to this agnostic solution. And maybe even you have one event store per service so that you can check again per service what is happening. Just one last thing, I wanted to talk about the pros and cons of the event store library. I think it's relatively easy to set up if you know how to do it, and I hope you have learned that today. I don't think it's that hard to understand once you understand the terminology, like streams and events and linking. It has good documentation, I must say, but it doesn't come with batteries included, as I explained earlier. I think this is a design choice so that you can customize it as you want, but it comes with a heavy buy-in depending on which architecture you use. And with only 15 seconds left on the clock, I would like to thank you. This is the link to GitHub. You can find everything there. You can also reach me on Twitter. with the handle PJ Ullrich. And now I would like to answer some questions. But I can already get started. I see the questions here in Hoover. I'm going to start at the top. How to get started with event sourcing. I hope I explained that to you. How do you handle read-side replays where underlying table structure and aggregates have changed? Full replay from event 0 in a new schema or projection promotions, i.e. a migration for missing data? It is a very interesting question, has a lot of CQRS buzzwords in it. I guess if you have problems with versioning of your events, there is an entire book almost completely written by Greg Young. It's almost complete. I also referenced it in the back. It's versioning the event store. I think we would handle it with a version flag. So in the metadata event itself, you put in a version number, and then you have consumers that handle certain versions of the event. If the underlying data structure changes entirely, so as I explained earlier with the Postgres schema that you buy into, then you have a bigger problem, I think. And I don't think I can help you with that. The question, event sourcing can assist in rebuilding a corrupt state. How are events formatted in the store to allow restoration of the system's state? As I showed you in the database earlier, this is basically how the events are stored. The payload, I said you can put into the data column anything you want. And you would use these events through the consumers I showed you earlier to recreate your application state. So you would just subscribe to the streams, and then you would say, you would have to write consumers that handle these events, like that handle the shipment registered event, and then create a shipment because of that. So you have to write that yourself. Okay, Martin, I'm just going on, right? You raise your hand if you want to say.
Well, I got my microphone. I got the capabilities of unmuting myself now, but you just go. You just go. You're doing good.
Thank you. The question, what are commons? What are differences in best practices compared to Kafka and Kafka streams? Oh, that's a very good question. I cannot tell you much about. My colleague Gregor is an expert on Kafka and wants to introduce it into our company a lot. But I cannot tell you much about it, I'm sorry. The only thing about Kafka I know, which is handy, which would be handy in our use case, is that it can store like all the events. It can store all the events for you. So you don't have to put it, so RabbitMQ thing in the middle, that's what we have. But the RabbitMQ doesn't store any events for you. You need to store them somewhere else. And whenever you create a new service, you need to publish all these events again for that new service. And if these events are in a service of a different team, that team will become annoyed by it because you will go to that team every second week and ask them to republish all the events, please. So in our case, Kafka, for example, would offer us the option to store the events. And then we, as a team who creates a new service, we can then go to Kafka and ask it to send us all the events that ever occurred on the system, if we wanted to. What is a good way to estimate if the complexity trade-off for using ES-CQRS is worth? Yeah, like I would like to quote Martin Fowler, and he says, be really sure that you need CQRS before you use it. So if you want to use CQRS, basically event sourcing has failed you. Like you cannot go on by only using event sourcing. And this, I think the obvious use case that is quoted most often is if you have very few writes to your database and very many reads. So if you have only a few processes that write and update the data, but you have many processes that read the data, and if that's a large scale system, then you might want to use CQRS. But Yeah, also from experience, I can tell you that it has a lot of complexity and it's very hard to else extract eventually again. Yeah. Okay. An event store grows over time. How can you handle it apart from buying more hardware? Is there any good advice you have to reduce the store size? Yes, an event store is growing. We don't experience any problems with storage. Like, yeah, and storage is pretty cheap, and you can just upgrade your database if you want to. So if you get to the point where this is a problem, you can use snapshots. And this is also a technique you would use if you use memory imaging. So if you have state in your process, in your memory, and you want to have a quick boot up time of your system, then you cannot wait for all the events that ever occurred in your event store to be published again and consumed again. So that might take a long time. In that case, you might say, I'm going to take frequent snapshots of my application state, and then go back to the last snapshot if I need to, and then only consume the events that happened after that snapshot. And this way, you don't have all the events, but you only have a few, and so on. Yeah, just look at snapshots of event storing and you will find an answer, I hope. Did you get into trouble with eventual consistency? Whoops. Yes. Consistency, it makes trouble if you don't expect it, basically. In our case, we mostly see that we have problems with it if we ignore events. Like, let's say you have an update event and you say, if I receive an update event, but I do not have the entity for it, I'm just going to ignore it. Then this will become a problem. Because then you might get the creation event after the update event. You create the entity, but you forgot about the update event, so you don't have the same application state. Okay. But yeah, most of the time, well, with the event store library that I presented today, you write your own backoff, exponential backoff functionality. And depending on how you write it, you might get problems with it. Because with us, unfortunately, if we can't consume an event in a certain amount of time, then everything will crash, basically. I'm just looking for the person who's
making noise.
Yeah.
I think it's down here.
Whoops, I got you. Okay, and then the last question, how using the event store data in a data science pipeline that generates statistical insights? How can you use the event store data? You can just use the Postgres database that you have and read the data from there, stream it through your pipeline if you wanted to. If you want to get the events right away when they occur, you can consume them, you can subscribe to them, and you can consume them. Yeah, I hope that answered your question.